Toxicology and Mould, an introduction. The following presentation is taken fundamentally from published research papers, and these are listed. So let's start with toxicology. Paracelsus, sometimes called the father of toxicology, wrote, "All things are poison, and nothing is without poison. Only the dose permits something not to be poisonous, or more commonly, the dose makes the poisonous. That is to say, substances considered toxic are harmless in small doses, and conversely, an ordinary harmless substance can be deadly if overconsumed." And I've used aspirins. So what is a hazard? A hazard is the ability to cause harm or adverse effects, basically. What is a risk? The likelihood that a hazard will actually cause you harm. For example, cyanide is a hazard, but the risk of it causing harm when in a stoppered, break-proof bottle is effectively zero. So what are the factors that influence the degree of risk? How much a person is exposed to the hazard, this thing or condition? How is the person exposed? And how severe are the effects under the conditions of the exposure? And again, we come back to our aspirins. So in order to effect a response, an individual must be exposed to the substance or the organism, such as in a house, mould, dust mites, volatile organic compounds, all kinds of stuff that one finds in the domestic environment. And the dose is determined by the degree of exposure, that is, time and amount. The presence of the agent in a building does not necessarily constitute exposure, and any exposure may be below the no observable effective level. Therefore, the degree of risk when exposed to a hazard will vary. Toxicity in the absence of a quantification of risk is meaningless. As we mentioned earlier, a material could be the most toxic substance known to man, but if the exposure and or risk is vanishingly small, then does it really matter how toxic it may be? And that's a question. Focusing on toxicity, irrespective of risk, leads to the presence equals significant exposure. Exposure equals significant dose, and significant dose equals illness. Therefore, presence equals illness. So what are the potential health aspects of mould? Well, toxicosis. Some fungi produce toxic substances called mycotoxins. These are toxic secondary metabolites present in fungal spores and hyphae. And of course, moulds produce a large number of volatile organic compounds, and this gives them their typical mouldy odour. We now come to the term toxic moulds. This term was given by the media. It is not actually a scientific description. There are 4 species of moulds that are considered to be in this group. Stachybotrys shutarum, or Stachybotrys atra. It's a brown-black mould that grows on cellulose substrates. It's very slimy, and it requires very wet, damp substrates such as following a flood. In other words, it's a tertiary colonizer. Penicillium species, some of those are considered. Aspergillus species as well, some of them. And finally, Fusarium species, some of them. So what are the detrimental health effects due to airborne moulds? Well, there are proven health effects. Most of these are from agriculture or occupational exposure. There's irritation of eyes, nose and throat, dermatitis, exacerbation of asthma, not its cause, allergy, probably the most common, and aspergillosis, also known as farmer's lung, and it usually affects immunosuppressed individuals. These are the ones that are at risk. The reported health effects, not proven: fever, flu-like symptoms, fatigue, coughing up blood, nosebleeds, dizziness, headaches, diarrhea, vomiting, and liver damage. So, what about exposure to moulds? Outdoor mould levels. Well, all one has to do is pass a field where they are haymaking during the summer and then measure moulds in the atmosphere there. But here's an example: seasonal variation in outdoor mould spore concentrations. And we are looking here at spore numbers at times of 50,000 in the sheltered areas, and even in the unsheltered areas or exposed areas, they're 25,000 spores per cubic metre. You don't get that in a building. Occupational exposures. Another here. Wood yards, 10 to the 6 to 10 to the 8. That's 1 million to 100 million spores per cubic metre. British farms, 1 million spores per cubic metre. Potting sheds, taking another one, 7,500 spores per cubic metre of Stachybotrys shatarum. These are pretty huge numbers. And by simply throwing a mouldy orange in a bin, there was a paper showing that over 200,000 spores per cubic metre were left in the air. So let's look at some of the references. German Mould Guide. Very rare and almost exclusively occurring in the workplace is extrinsic allergic alveolitis, which is generally produced by repeated exposure to very high concentration of spores, that is 1 million to 100 million, which cannot be expected to occur in residential properties, basically. And anticipated systems by atopic persons. Atopy is a predisposition, get it right, towards developing certain allergic hypersensitivity reactions. So there we go. Look at the spore counts and the results. These are from people that are sensitive to these things. And this data comes from the American Academy of Allergy and Immunology. Mould Facts for Patients, excellent piece of work, extracted from Professor Richardson's Mould Facts, Mycology Reference Centre, Manchester. Again, moulds on the left, and what do we say for the health risk? Potential allergy, immunocompromised for Aspergillus fumigatus. Again, going down the list, we can see opportunist, and toxins and human health, no conclusive evidence frequently. Alternaria, toxins listed, Fusarium, toxins listed, and Stachybotrys shatarum, toxins listed and actually produced. Quite the information. Where do these come from? Indoors. It's got a list there where we get them from. All environmental moulds can, but not necessarily do, produce mycotoxins. Again, more quotes. This is basically the result of the WHO, World Health Organization, and the Institute of Medicine in America. It says, in that study, the IOM stated there was insufficient evidence to find a causal association between the presence of moulds and any of the claimed adverse health effects. That is, after reviewing the global and scientific medical literature, the IOM could not find sufficient evidence to support the argument that the normal presence of mould in residence and workplaces caused any adverse health effects. And again, they are consistent with other organisations and authorities. Health Alert, published by University of Health and Johns Hopkins Medicine. Again, it says, it is highly unlikely that you can inhale enough mould in your home or office to receive a toxic dose. Goes back to our dose equals amount plus time. Sick building syndrome. Again, here we go. This is from Mycotoxins, a journal. There is no evidence that mould presents an imminent threat to life for healthy members. Typical indoor exposures. The concentration of mould contamination required to create infective doses is improbable and inconsistent with the reported spore concentrations in buildings. Current scientific evidence does not support the proposition that human health has been adversely affected by inhaled mycotoxins in home, school or office. Again, American College of Occupational and Environmental Medicine Council evidence-based statement. Finally, it's the same arguments and the same information with reference to guidelines, New York City Department of Health. That's their views based on data. So, the mere presence of such a mould should not be taken as evidence that the mould was producing any mycotoxin. For a toxic effect to occur in a subject, the toxin must be present, there must be a route of exposure, and the subject must receive a sufficient dose to have a toxic effect. So what do we conclude? Or at least from the Journal of Allergy, Clinical Immunology, the occurrence of mold-related toxicity from exposure to inhaled mycotoxins in non-occupational settings is not supported by the current data, and its occurrence is improbable. More again. 2 reviews, health risk of dampness or mould in houses. One review concluded that combining the elimination of moisture intrusion leaks with removal of mould is effective in reducing allergy, etc., etc. And the other one again, there was moderate evidence that remediating dampness and mould problems in houses. So we can see where we're going with these stuff in removing dampness. So therefore, based on peer-reviewed documents and literature, the fundamental problem is a long-term damp environment. It is these long-term damp environments that give rise to moulds and dust mites and the rest of these items. All these are associated with a damp environment. Toxic moulds are therefore certainly nowhere near as devastating as some of the media and some individuals would have us believe. They are only likely to affect sensitive, i.e. atopic, and immunosuppressed persons. By far the greatest proportion of the population will not be affected. So the evidence so far, that is the published evidence from science and medicine, suggests that moulds as an individual component in a damp internal environment are unlikely to affect healthy individuals. It has been concluded that there was an association between damp living spaces and some adverse health effects, but no one's been able to demonstrate conclusively that the association is exclusively due to the presence of mould. There's a whole mixture of items in a damp environment, and as such, the stress is placed on correcting the damp. We mentioned the word association. What do we mean by an association? Well, it's the weakest of all epidemiological evidence. What it means is simply an observation occurs with another observation without further quantification. For example, the last person who lived in this house died of lung cancer. The last 5 occupants of this house died. Fact, occupancy in the house is associated with death. Fallacy, this house is causing people to die. Fact, virtually all people who have died have lived in a house. Absolutely all people who have lived in a house will die. Association is the weakest of all epidemiological evidence. So to summarise then, whatever the case, the risk of health problems is greater in a distinctly damp environment than a dry one. It is essential to get the building back into a suitably dry state, irrespective of how the occupants review it.